Hi and welcome to my second video in the series about blood and transport system, and today we're going to be looking at vasoconstriction and vasodilation. So within exercise we need to redirect blood to different areas of the body, and so the way in which we can do this is we can either vasodilate, which means to open, or to vasoconstrict certain arterioles. And what this can do is this can either stop blood in the case of vasoconstrict, or to allow blood, vasodilate, to get to certain areas of the body. And obviously when you're exercising, the blood supply needs to be changed to different areas, and so therefore this mechanism of being able to move blood into different areas or to stop it going to others means that you can meet the demands of the exercise. So this diagram illustrates the difference between the blood flow changes during exercise. So this is at rest and this is your value for exercise, and you can see straight away that the amount of blood going to different areas has increased massively, and so it's nearly trebled, or in fact it probably has just about trebled. So 5,800 millilitres per minute and nearly 18,000 millilitres per minute. What you'll notice here is several parts. So if we explain each part here, so with the brain, the amount of blood going to the brain remains constant. The reason for that is the brain needs a constant supply of glucose and oxygen to have the CO2 removed so it can function properly. And so the blood supply to the brain, regardless of exercise, never changes. The heart has an increase in the amount of blood flowing to it, so the reason for that is obvious. The heart is contracting more during exercise, and therefore it needs a greater supply of glucose and oxygen. The skeletal muscles increase massively, so in the order of 6 to 7 times the increase goes up by. The skin increases the amount of blood that flows to it, and the reason for that is you can cool down by sending the blood to the surface of the skin. It enables more of the heat to radiate and to convect and conduct away from you, and so therefore it can cool you down. The kidney, the amount of blood reduces to there, and so the process of producing urine, or the process of, particularly to do with this one as well, the abdomen, so to do with digestion and excretion, that slows down during exercise because it's all being redirected to the muscles. And to the other areas of the body you have a reduction again because that blood is being redirected to the skeletal muscles and to the skin and to the heart, which require more oxygen and glucose to respire. And so the two methods to cause the redirection of blood, one is vasoconstriction. That means to reduce the flow of blood into the capillaries by action of the sympathetic nerves, and vasodilation, increasing the flow of blood into the capillaries. And it's specifically the arterioles are the ones that contract that cause this. And so this is why they have the smooth muscle material, or big amounts of the smooth muscle material found within the walls of the arterioles to do this. So that smooth muscle can contract, and therefore it can constrict the blood flow, or it can relax and therefore dilate and allow more blood flow to that area. If you look at the diagrams here, it shows under vasodilation, and so the lumen size is bigger. Under vasoconstriction, it shows it being much smaller, and so that smooth muscle is contracted. And so we can think of vasoconstriction happening to the arterioles surrounding the kidney or around the abdomen. Vasodilation would occur to the blood vessels that supply the skeletal muscles, and also the blood vessels that supply to the skin, which will enable you to cool down. And so when you exercise, you know more blood flows to the surface of the skin, and therefore it enables you to cool down, which is why that you see when you run around for a long period of time, you appear red because lots of the blood is moving to the capillaries near the surface of the skin. When you're cold, the blood moves selectively towards the organs, towards your vital organs to promote survival, and therefore you appear blue. Well, if you appear blue you're probably in trouble, but essentially you appear more pale if you're colder. If you join me on the next video, we'll be looking at blood velocities and blood pressure.